Wait, so does anybody? Sorry, what?
Oh, I was about to say, if we pulled up a quiz.
Well, I was just gonna ask, like,
About questions?
Yeah, does anybody else have questions? Because like, I had that question we asked earlier.
Yeah.
What question did you have? I like the last two questions on the part 2 of the assignment sheet. I like didn't understand them, but like they explained like because it's the mean of like a normal distributed chart, like the mean and the standard deviation are the same for the mean of the mean scores.
Like
for number
8,
7.
question C.
Yeah, 8C.
What is the mean of the sample distribution of the samples?
Okay. Yeah, I was a little bit confused, but
because the way they ask the questions, they sound like
it is worded kind of differently, but it should be the same.
Too many samples.
And I emailed the teacher, by the way, before I forget.
Oh, yeah?
And she said that if we could do it in one meeting, that's efficient, and she doesn't care.
Okay.
Oh.
So if we can get it all done in one meeting, we can do that. She said that's fine. So we would just say, hey, this is for both lessons or whatever.
I definitely didn't prepare for lesson 7 yet.
No, that's okay, and I think it'll be okay because we didn't know.
Right.
Because I wasn't sure, because I got the answer today. So
like starting next week, we could do that.
We can start trying to get it. And then if like we're like Tuesday nights getting long and we're like, okay, let's just wait till Thursday, then we still can.
Yeah.
But she said that it's efficient if we can get it done in one day. She's like, yeah, I'm not gonna tell you no.
That's awesome.
Get it done, get it done.
I had my doubts, but I'm glad that she said yeah.
So
Alright, so the quiz now?
Mm-hmm.
Group meeting quiz. Lesson 6, right?
Yes.
Lesson 7.
Mm-hmm.
Now lesson 7. Let's not make that.
Don't pull a Heidi.
Yeah. That was bad. I think each of us are probably gonna almost do it once this semester or do it once. I almost, well, luckily, like you said, with the homework, you can save it for later, but like I opened the wrong homework. It's like that. That wasn't supposed to happen. True. True. I actually have used.
Yeah.
See how this goes. Oh yeah.
Hopefully we won't.
Okay.
Hopefully we won't need it though.
Okay. It's the same. 'Cause I was freaking out thinking it was the one with the guy.
Okay, is question 3 just trying to like throw me off?
Nah, it's skewed, right?
Okay, that's what I thought. Whew.
I don't know if they like clearly define what is like a large sample size though.
Well, I feel like
Is there a definition of what suits a large sample size?
I think it depends.
Hey, Dad, sorry, I'm in a group meeting right now. Can I call you
afterwards?
afterwards?
And then
Okay,
5,000
sorry.
times.
Yeah.
So
I love you too, Dad. Bye-bye.
in the videos.
The hundreds of 36 episodes.
Oh yeah, so it should be normal. But that's what I was trying to figure out is like, where do they draw the line? You know what I mean?
It's asking us,
Right.
so when you're taking sample size of this, what is the shape of the distribution of the means? If you're just saying the sample, but it's asking for the means after you do it, the means of 100 samples. Yeah, that's why in quotation, the distribution means what's the shape of that.
Well, all it's asking
Right.
like though is if it's small enough, like if it could be right skewed or it could be a normal distribution, but if the sample is small, then it could be either or, but if it's large, then it doesn't matter whether or not it's right skewed or left skewed or normal, then it's always going to be a normal distribution. So I just like wonder where that is defined, you know what I mean?
Yeah, I would say like for this sake, like n equals n equals 100 is probably a large distribution.
I just hope they keep it obvious. But
Yeah.
who knows? Because like I think 25 was still like a right skewed on an example
Yeah.
I saw somewhere. So
So then for 5, because it's normally distributed and it's a small sample.
yeah.
Shares. So for number 6 is normal, right?
That's what I got, yeah.
I feel like these are trick questions, but they're not. Like it's just making us use our brain. The distribution. Distribute up. When. That's right.
Yeah, when you guys get to question 8, I have.
Sounds good. Okay, central limit theorem.
Yeah, that's the one I was confused about.
So
I said it was C.
the central limit. Yeah.
No, that's the large number theory. The central limit theorem is more about the bell curve and the shape of it.
So is it D? If the sample size is large, the shape of the distribution of samples will be approximately. Okay. Those two are confusing.
So
Central limit theorem is defined as sampling distribution of sample mean will be quote unquote normal if the sample size is sufficiently large.
you brought it up several times in the video, but it seemed like you worded it different every single time. Had the same thing, but I felt like
Yeah.
every time we pulled it
Oh,
up,
I know.
and I was like,
I don't like his
not the
voice.
same
Puts me to
definition,
sleep.
right? Or he says something really fast and quiet, and you're like, pause, replay. Okay, with the X. Population. Population. What is it? Calculator. It's not divided by what? It's actually
It's 10.
oh, because it's asking for the mean, not the.
Not 10, nope.
Okay.
Now 10 is standard deviation. And so
Deviation of the distribution of sample means that it's going to be the deviation divided by the sample. Okay. So 6 divided by 6.
it's 1. Yeah.
Wait, 6 divided by, so 6 over 36, is that?
6 over square root of 36, which is 1.
I was just
For
like,
10?
no, that
Yeah.
is not how that works. This way. I did not like that. So we should actually do that.
Is 9 the same mean as? Yeah, so like is 9, yeah, 10.
Mhm.
Okay.
Over 30, oh, okay.
Maybe that's the definition.
There we go. Just define it for us. Over 30. What does sample mean? Normal. I feel like it's asking us in all the ways it can ask us.
Right.
I feel like the first lesson each week is easier, and then it's like a harder one. Central limit theorem.
I thought it was a lot of large numbers.
Wait, but then wouldn't that be the same as question 8?
Central limit theorem, as the sample size increases and becomes large, the distribution is, oh no, that's the central limit. A law of large is as the sample size n increases, the sample mean draws closer to the population mean. Oh, so law of large numbers is mean, it's like dealing with the mean. Just kidding.
So it's still central limit theorem.
Yeah. Apparently.
Well, I'm gonna hit submit, see what I got.
Fingers crossed.
Well,
Yay!
did you get it? Okay.
Yeah. 100%.
Wow.
Yes.
Guys, we're done. And it's
7?
wait.
Everything
Seven.
except for C. Everything except for data are drawn from a population that's right skewed and sample size is small.
Wait, so it's in, so I've only got 2 marks for that one. For number 7. So you guys marked 3 of them?
Mm-hmm. All of them, but data are drawn from a population that is right skewed and the sample size is small.
So like if the population is normally distributed and the sample size is small.
Oh, it's still gonna be norm. Okay, that makes sense. I was looking for large sample sizes. Okay, that makes sense. Okay. Distribution would be normal. Okay. That makes sense. Okay. Oh, that makes me really happy, guys. Like, seriously. Responses, go to submit quiz.